Hello Math 30-1 students. We are on our last lesson of the Transformations unit, Lesson 8, and we're looking at still combining transformations. Okay, so this is where we put it all together. Here's kind of our basic transformation equation, which is on your formula sheet for the diploma. And A, when it's on this side, so it's not with the Y. Actually, let's start with the X stuff. Okay, so this B in front of or being multiplied by x is related to the horizontal stretch factor. So the horizontal stretch factor is 1 over b. Minus h would move the graph left or right h units. And if it's x minus 2, let's say, that would be right 2 units. Okay, now and the negatives too. So if b was negative, less than 0, it would be reflected in the, let's see, x goes negative, so in the y-axis. Okay, and then now let's look at the vertical stuff. We have a being multiplied by the whole function. So that is a vertical stretch. It's not with the x, so it's a vertical. It used to be with the y. When it's over here on this side, it works normally, so it would be a vertical stretch factor of just a, whatever that is. And this k is not inside the function with x, so therefore it's related to y. And so that would move the graph, if you add or subtract, that moves the graph up or down, and in this case up k units. It works normally when it's not with the y. Okay, so that kind of summarizes all this. When you go to graph transformations from an equation, you want to use the following order: stretch, reflect, translate. So just think of the word sorted out to remember that order. Stretch, reflect, translate. Okay, so let's put this all together to do example 1. Oh, and there's one that wasn't mentioned up there. Sorry, let's go back. One that wasn't mentioned was a reflection in the line y equals x. And that would look like this: x equals f at y. Okay, and of course we can combine any of those or two or more of those, really, transformations. Okay, example number 1. The graph of y equals f of x is shown. Consider the function defined by the equation y equals 2 f bracket 1/2 x plus 5 in bracket minus 8. Okay, if the equation is written in the form yada yada, which it looks like it is, isn't it? The key thing to note here, though, notice this b is factored outside of the brackets, right? It's not inside the brackets with x. And that's important for determining what the horizontal shift is, or the horizontal translation. Okay, so keep that in mind. It's fine on this question, but we have to look for it on future questions. Okay, state the values of a, b, h, and k. Okay, so a refers to whatever's in front of the whole function, so that would be 2, a equals 2. B would be the value in front of x, which would be 1/2. H, now normally this sign is negative, right, inside the brackets. So if we compare to this equation, that sign changed to a positive. So it must have been minus -5. So our value of h would be -5. Okay, and our k value, which they've got it placed here, we just read off as -8. And there we go, there's all our values. Okay, part B, write the transformations associated with those values. Okay, so for a equals 2, that would be a vertical stretch by a factor, and I'm going to abbreviate that to BOFO, by a factor of 2. Okay, just to shorten that up a bit. B is with x, so that's a horizontal stretch by a factor of 1. Oh, yeah, that one we have to flip, don't we? Because it's with x. So that has to be by a factor of 2. The a value was not with the y, So we didn't have to reciprocal the A value to get the stretch factor. However, the B is with X, and so therefore we do have to reciprocal it. So that goes back to a previous lesson. When the coefficient is with the letter that it applies to, then you always reciprocal to get the stretch factor. Okay, now H refers to, so if we have X plus 5, that's going to move it left 5. And minus 8 at the end is going to move it down 8. So that works normally because it's not with the Y as well. And the H, or the plus 5 that was in with X, that works opposite because it's with the letter. Hopefully I don't lose my voice before the end of this video. Okay, so part C, put these transformations in order, which can be used to sketch the graph of a function, and then sketch the graph. So if you'll notice, so the in order part they're talking about is sort. And I believe we've done that up here, so we're okay with that. We don't have to rearrange the order. But now we need to sketch it. So it helps if we find some anchor points first. So 0, 0, find places where the graph goes through the grid lines exactly. Okay, and for parabola, that happens, you know, basically where x is 1, y is 1 squared, because it's a parabola. Where x is 2, y is 2 squared, which is 4. So that's where these points are coming from. Okay, so we are going to vertically stretch and horizontally stretch by a factor of 2, and then move it left 5 and down 8. I'm going to actually do that to one point, all of those transformations, and then connect them all so we don't have 5 different graphs on here. So this point 0, 0, when we stretch it vertically, we're stretching it about the x-axis, so it will not move. That point is invariant for that transformation. Horizontal stretch by a factor of 2 about the y-axis. Again, it won't move because it's on the axis. Left 5 over here and down 8. So that point now moves to there. Okay, let's do this point here, 1, 1. So if we vertically stretch that, I'm just going to use a different color here. If we vertically stretch that by a factor of 2, this y value of 1 would now be a y value of 2. Okay, horizontally stretched by a factor of 2. Okay, it has an x value of 1. That's now an x value of 2, 1 times 2. And then we move that point left 5, 1, 2, 3, 4, 5, and down 8. So we're at 2 minus 8 is going to put us at negative 6. That's easier than counting, isn't it? All right, let's do this point here. So we're at 2, 4. So vertically stretched by a factor of 2, the 4 for y would become 8. Okay, horizontally stretched by a factor of 2, our x value of 2 would become 4. Okay, and then left 5 over to here and down 8 would put us at negative 1. Now we're going to use symmetry to do the rest, right? We know all these points were the same distance away from this axis of symmetry, so why don't we just use that? So this point, which was 2 away, will be here. This point was 4 away, would be 4 away on the other side. Okay, and there we go. We've got our graph. And that looks pretty good. We can test it out. Oh no, can we? Yeah, if we had the x squared, we know it's y equals x squared. So we could actually test it out in there, but I think that's a later question. So let's take a look at the next page. Aha, I told you it was a later question. Okay, so the original graph has an equation y equals x squared. Write the equation for the transformed function. Okay, so what they want us to do is they want us to, good to know, they want us to use these transformations in this equation. Now, I personally find that easier to kind of start over and go vertical stretch by a factor of 2 from the previous page, horizontal stretch by a factor of 2, left 4, and down 8. Oh, sorry, left 5 and down 8. Okay, and I would next do the replacements for those. So if we vertically stretch by a factor of 2, y gets replaced with 1/2 y. Or you can put it in front of the whole function like they did, your choice. X gets replaced with 1/2 x, and then x would get replaced with left 5, so x plus 5, and down 8, so y gets replaced with y plus 8. Okay, now if we combine these two, that would actually turn into 1/2 brackets because the translation was done secondly. So we'd be scooping x out after we did the stretch. And we'd get that for our replacement for x overall. To do that with y, okay, we'll just do that down here. Y would get replaced with, first we did the stretch, then we scoop out and do the down 8. So y plus 8. And there we go. Let's take our y equals x squared. We're going to replace y with 1/2 y plus 8. Replace x with 1/2 x plus 5 in bracket and then in bracket squared. There we go. Now we're not done because they usually want it in y equals form, right? So we still have to, actually before we move stuff over, we're going to simplify the right hand side a little bit here. So we're going to, actually this would be okay normally to leave it like that. And they might want to see that 1/2 inside the brackets. So I tell you what, we will bring everything, isolate y, right? So to do that, we're going to multiply both sides by 2. Okay, you cannot multiply the 1/2 and the 2. Why? These brackets have a squared on them, okay? So you can't cross that barrier because this 2 is not being squared. Okay, that would get rid of this over here. And we'd be down to y plus 8 equals 2, 1/2 bracket x plus 5, bracket squared. Okay, now we're going to subtract the 8 over. Minus 8. And there we go. Looks pretty good. And it looks a lot like this, which it should, right? Now we could, as I said, simplify that a bit further if they wanted to go further by squaring the 1/2 and squaring the x plus 5. So to do that, we would have, when we square the 1/2, square the top, square the bottom, we'd have 1/4, square x plus 5, which means just writing it as x plus 5 squared, minus 8. And one more step, 2 times 1/4. 2 goes into 4 twice, 2 is on top, and we have 1/2 multiply 1 times 1 over 1 times 2, and there we go. By doing this, we can actually graph that now and see if it's the same as our sketch. So I'm going to leave that up to you guys. If you want to pause the video and graph this in Y1, and then compare it with your graph on the previous page, make sure it's the same. Find the vertex, make sure it's at the same place. All right, good job. Hopefully that graph compared well. Okay, let's take a look at example 2. Okay, the graph of y equals f of x is shown. Sketch the graph of y equals -2 bracket f of x minus 3 plus 1. Okay, so before you just jump into this, you need to write down your transformations, even just in abbreviated form for your own reference. And remember the order, sort it out, right? So stretch, reflect, translate. Okay, so do we have any stretches? Any numbers being multiplied or multiplied on the function or by y or by x? Yes, we have a 2 being multiplied. So it's not inside with the x, which means that 2 is going to be a vertical stretch. It's implied to be with y. It's not over here with the y, so it would work normally, vertical stretch by a factor of 2. Okay, there's no horizontal. There is a negative. Negative is a reflection, so we have a reflection next. Okay, and that's going to be not with the x, so it's not negative x, it's negative y, so over the x-axis. Okay, and then we have some translations. You guys are going to write those down. Pause the video. Okay, I was hoping to finish this video before the end of 15 minutes, but we're not going to be able to. Go ahead and work on this and do these transformations, okay? We'll check in part 2 of the video.